Let's finish this lecture by solving three problems, 9, 14, and 20. Problem 9. Calculate the resistance of a piece of copper wire that is 1 meter long and has a diameter of 1 millimeter. So what is given? Length of the copper is 1 meter. Diameter is 1 millimeter. Let's convert that to meters right away. So it's 10 to the negative 3 meters. We also need to know resistivity of a copper, and pretty much set. We're looking for resistance. R is question mark. The formula is resistance is given by resistivity multiplied by length and divided by cross-sectional area. Area of a cylindrical wire is equal just pi r squared. That would be pi d squared over 4. Because the diameter is equal to radius, and radius is equal diameter over 2. Plug in over here. Resistivity we need to look up in the tables. Table 19.1 has a value for resistivity, and it is equal 1.7 10 to the negative 8 ohms times meters. Now we're ready to calculate resistance. Resistance is equal resistivity 1.7 10 to the negative 8 multiplied by 1 meter divided by area. That's going to be pi 3.14 times 10 to the negative 3 squared, and divide by 4. Instead of divide by 4, we're going to multiply the whole fraction by 4. That's the formula. And there's a number, so if we plug it in into our calculator, the answer we're going to get is 2.2 10 to the negative 2 ohms. Okay, let's go to the next problem. Problem 14. An aluminum wire has a diameter of 0.5 millimeter and a length of 7.5 meters. What its resistance? So this very similar problem, just different numbers. We are given diameter 0.5 10 to the negative 3 meter. We are given length 7.5 meters. We can look up resistivity in a table for aluminum. That is 2.7 10 to the negative 8 ohms times meters. And we're looking for resistance. Resistance question mark. Same formula as before. R is equal rho L over A is equal rho L for pi, pi diameter squared over 4. That is rho 4L over pi diameter squared. Plug-in values is 2.7 10 to the negative 8 times 4 times 7.5 over 3.14 times 0.5 10 to the negative 3 squared. And the answer is approximately 1.0 ohm. That's it. Let's go to the next. Problem 20. There is a potential difference of 20 volts. So given potential difference 20 volts across a resistor with resistance 50 ohms. What is current through the resistance? Current question mark. So the form of Ohm's law I usually remember, voltage is equal resistance times current. So current is equal voltage divided by resistance. Plug-in values 20 divided by 50 is equal 0.4 amperes. So answer is 0.4 amperes. So that's it for this lecture.